Welcome to today's webinar, New Frontiers in Unmanned Flight, Hey You UAV, brought to you by GPS World Magazine and our sponsor, Navcom. I'm Joelle Harms from North Coast Media, digital producer for GPS World Magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. A recording of this webinar will be posted to gpsworld.com/webinars and will be emailed to you tomorrow. At this time, I'd like to acquaint you with ways you can participate during today's presentation. Please notice the Submit button in the lower left-hand corner of your console. Just type in the text box at the bottom left and click Submit to place your question in queue. We encourage you to ask questions throughout the presentation. Our Twitter feed is placed in the upper right corner of your screen. You may also use the hashtag GPSWorldWebinar to submit any questions during today's webinar or to enter into discussions with other attendees. You may learn more about our speakers by viewing their photo and bio in the upper left-hand corner. And if you're logged into any social media accounts, feel free to share the webinar's title, description, and URL with your friends or colleagues on any social media sites, all within the Share This widget, which is at the bottom right of your screen. If you aren't already a GPS World Magazine subscriber, we'd like to invite you to sign up for today for free. All you have to do is click the GPS logo at the bottom of your screen in that little dock and fill out a short form. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Allison Barwatz or I will personally assist you. Now I'd like to turn today's event over to our moderator and publisher of GPS World and Geospatial Solutions, Alan Cameron.
Thank you, Joelle, and welcome everyone to New Frontiers. We've got a wide-ranging look at unmanned flight today with the emphasis on the U in UAV. There's a slight distinction, there's an important distinction, I should say, between unmanned and autonomous flight. The two overlap but are not identical, and that should become clear during the course of this webinar if it's not already clear to you. As I said, we have a wide-ranging look at the topic from several different perspectives. First, we're going to hear from Tony Murfin, who's our professional OEM editor, and as of today or a week ago, he's also our UAV editor. Tony has been focusing on UAVs in a number of his monthly e-newsletters, and we're going to go ahead and make that a regular topic for him. So we'll have regular coverage in this space besides our news stories on the website, regular editorial commentary on UAVs from Tony. Tony's going to give an overview of the market and some recent important news developments. Then we're going to go to Donald Chance Mark Jr., who's an attorney in the field, and he will cover the current state of regulations, which particularly in the U.S. is a key point in UAV development. After that, we'll hear from two researchers from a Stanford team. I'm talking about James Spicer and Adrian Perkins from a Stanford team who have conceptualized and actualized a task-specific UAV. Their Jaeger project is the subject of the cover story in this month's GPS World Magazine, if you haven't already seen it. They're going to give us a close-up look at an actual cutting-edge UAV. Finally, we'll go to Peter Kosin from Trimble's UAV division, who will take us through a commercialized UAV product, one that is fully developed, is on the market today. You can buy it. Then depending on your location and your exemption status, you may or may not be able to fly it, but it is certainly available on the market, and Peter will give us an idea of the applications it's targeting and its actual use. Finally, we will have your questions. I've seen a record number of questions come in as you signed up for the webinar, a record number of pre-submitted questions. We'll also be taking questions live during the course of the webinar through the channels that Joelle described, and we'll return it for the final 15 minutes of the webinar for question and answer. So submit your new questions, and I will make a selection from the pre-submitted ones and the new ones. That's it from me for now. I'm going to turn it over to Tony Murfin, GPS World's professional OEM and UAV editor. Tony, take it away.
Thanks, Alan. So hi there. I just flipped backwards and forwards there. I'll push my slide here. Here we go. So I'm Tony Murfin, the OEM and recently promoted UAV editor for GPS World. UAVs are making a lot of news, and at the recent AUVSI meeting in Atlanta just a couple of weeks ago, well, a week or two ago, there was a lot of new news on UAVs. So today we've put together a bunch of information and an informative session, I hope, on several aspects of UAVs, and I'm going to concentrate on what we're trying to do to get, or what's been done to try and get UAVs into commercial applications in the U.S. So at AUVSI, the first thing I noticed was that there was a lot more TV coverage than there has been at previous meetings, which means it's picking up interest in the media, which means that more people are looking at UAVs. So both the Today Morning Show and Fox News were there, both running live broadcasts from the show floor. Today featured a simulated drone delivery. The announcer opened a door and there was a drone waiting with a package, like it had just come from Amazon to your front door. And then Fox carried a live demo of the high-definition video over Ammunium Connect's wireless link. So that's another aspect of how we get high-definition pictures for filming, for surveying, for monitoring across to the ground. The other interesting piece of gossip I picked up, if you like, was that people in the past have it's been a dialogue between the media and the industry about whether we call these unmanned aircraft or UAVs, or the TV and media like to call these drones. So what I discovered through talking to a number of people and listening to the hubbub was that the industry's acceded to the media definition. So now we can call them drones or we can call them UAVs, and I guess we don't have to feel embarrassed about either. Just a piece of interesting nomenclature. So the important part of my presentation here is that the FAA, the Federal Aviation Administration, was at AUVSI, and it was there in force, bringing the administrator himself there, talking about what has been done to introduce UAVs into commercial usage. And this is a highly interesting area, and the FAA is getting a lot of heat from Congress and from the Senate to get on with it, because they're falling behind. The U.S. appears to be falling behind other countries. So they have taken steps, and under their the existing laws, they have granted about 340 exemptions allowing the use of U.S. commercial drone use. But their proposed rulemaking for smaller drones, which are these quadcopters and the things you see on the Audi adverts, those are still mired in where's the regulations? And the regulations were published and for comment, and a whole bunch, 4,500 plus comments hit the FAA. So they're struggling to move forward and get that resolved. So it could be that even during this year, when the legislation calls for them to have commercial UAVs in operation in the U.S., they might not make that date. But they did announce a couple of key initiatives. The Pathfinder project, working with CNN, will work on more intensive use of drones, UAVs in populated areas. The regulations currently say you shall not fly over the top of anybody. So that project will be carefully monitored. And two other projects with Precision Hawk and BNSF Railway, they hope to work on projects which are also very key. The range that drones can operate, UAVs can operate, is currently restricted to how far you can see them. So if we get to a place where we can operate much further, beyond visual line of sight is the term, then this opens up a lot more applications, especially for things like the railway, where long-distance inspection of railway lines and facilities are important. The FAA also introduced an application. I don't think it's published yet, but they're working on it, that will help recreational drone flyers. They've been affected significantly by these new coming regulations. They see their right to fly being infringed. So here's an application which will let them know that there's where it's safe to fly. Here's a smattering of examples. We've got Amazon, Swiss Post and Swiss World Cargo, and Google, and even Delft University in Holland. They're all working on delivery systems for packages, for different aspects of what you could do with a drone in taking things to somebody. So Amazon has a patent that they've just lodged with the patent office, and they're moving towards working with directly with smartphone information in customers. The Swiss Post Office wants to make a test of drone mail delivery this summer. Delft University has a really neat application which flies one of these defibrillators to directly to heart attack victims. So call up a number. A few minutes later, a drone shows up. You pull out the paddles and resuscitate your injured relative. Really neat. And Google's got a fairly high-flying drone with solar-powered wings, which would be able to broadcast Wi-Fi in areas where they can't currently get to subscribers. So this is just a smattering. There's thousands of UAV applications underway. The last piece of my news is basically that new bills on the books from the Senate. Senator John Hoeven and Senator Cory Booker both put forward a proposal which would really take all the things that the FAA's put into their exemptions and turn them into law. So the previous regulations, would you say, that the FAA's allowed people to use, they don't have to. People don't have to mess with exemptions anymore. It becomes law. 6 test centers that the UAV has set up would be able to register vehicles. That's something you can't do currently, and administer knowledge and proficiency qualification for drone operators. And then a deputy administrator position will also be created. That would give us a person, a focal point, somebody who's going to manage all these activities in the U.S. and there's a lot of tight time frames in that bill. So they hope the bill will become law in this session, or at least before the end of the year. So to summarize, media was much more interested at AUVSI, and there was a lot of coverage. We can call the UAVs drones. It's okay. FAA is trying to keep up the pace, but they're having difficulties. But there's new initiatives which seek to bring things on quicker. There's a lot of new applications, including Amazon, Google, Swiss Post, and University of Delft, just a smattering of examples. And there's a new Senate bill to try and overcome some of these FAA delays. So that's basically my presentation, Alan, if you'd like to pick it up and take it further.
All right, thank you, Tony. You've amply earned your new boosted salary. And for readers and listeners out there, you can look for some UAV content in every issue of Tony's professional OEM newsletter and a focus on UAV in every other issue. He'll start alternating columns dealing largely with UAVs with some of the other professional OEM concerns as this segment assumes more and more importance. We're going to turn now to a very key aspect of this industry development, as Tony alluded to, which is the regulatory picture and the legal status or lack thereof of actual UAV operation in the United States. And for that, we turn to Donald Chance Mark Jr., an aviation attorney with the firm of Fafinski, Mark & Johnson. Donald, it's yours.
Thank you, Alan. What you have just seen is a wonderful piece of marketing by a company called Lake Made Beer. They have run this commercial and obviously hope to be able to use the technology that's demonstrated for a commercial purpose. Other companies, TGI Fridays, for example, had a promotion over the holidays where they had a mistletoe that was carried by a DJI within one of their stores in New Jersey. There are ample aerial photography companies that have been utilizing this technology, as well as various farm operations. But the truth is, what we just saw from Lake Made with the lack of permission from the FAA is absolutely illegal, as are the other operations that I've generally described. So we're going to take just a little time and talk about what is required and how you go about making sure that you're legal when you conduct commercial operations. First, under the FAA Modernization and Reform Act of 2012, just to review, the FAA views unmanned aircraft as aircraft operated without direct human intervention, either from within or on the aircraft. And unmanned aircraft systems are systems and their associated elements that are required to operate safely within the national airspace system. And I might point out that the FAA takes the position that the national airspace system is from the ground up, and they control all of that. So there are three basic ways to obtain FAA approval for commercial operations. I'm going to just identify the first two, and then we'll concentrate more on the third one. The first one is called the Special Airworthiness Certificate or Experimental Certificate. This is generally for non-revenue activities and is usually limited to research and development, crew training, and the like. So, for example, a university might seek, in conducting its operations on campus, perhaps with an agricultural school, for example, might seek this type of certificate. The next one is called a Certificate of Waiver or Authorization, frequently referred to as a COA. This is typically given to federal, state, or local governments, oftentimes law enforcement. And private companies can also work with governmental agencies. So, for example, a private company might partner with a county or a city to overfly city property or county property to determine control of the environment in terms of erosion, those kinds of things. The one that I want to concentrate on in the limited time that we have is what's called the Section 333 exemption, which is an exception to the federal aviation regulations. And this is the exemption that allows for lawful commercial operations under specific circumstances. And this is the type of exemption that is being given by the FAA now until there is a final proposed rulemaking, and I'll address that in just a few moments. But generally, the steps for obtaining the Section 333 exemption is to identify the intended use, identify the areas of use, identify and retain qualified operators, prepare operational manuals, prepare maintenance manuals, have an operating procedure and the like. And then that takes a petition form. It is produced and provided to the FAA, and they make it public. And there is then a 90-day period for public comment after the petition is filed with the FAA. The public has the right to either endorse or to object to or make comments with respect to the proposal. After that 90-day period is over, the FAA acts on the petition, and if it is granted, they provide the conditions and the limitations of usage. Now, what we've seen, and just to amend a little bit what Tony has said, as of last week, we counted 397 petitions that had been granted by the FAA. I will tell you that initially when the petitions were starting to be granted, there were very few, and it was a very lengthy process. Now there are categories, whole categories of petitions that are being granted, and it seems like on a weekly basis, whole groups are being granted regularly by the FAA. Generally, what we've seen in terms of trends, the UAS must weigh less than 55 pounds. It's limited to 400 feet of operating altitude. Currently, the pilot in command must have a sport pilot license and a valid driver's license. And that's a change from many of the initial exemptions that were granted. Initially, you had to have a private pilot's license in order to properly operate, and you also had to have an FAA-issued medical certificate. When the Notice of Proposed Rulemaking came out, those two requirements were lifted, and instead now a sport pilot license, which is less burdensome to obtain, and simply a valid driver's license would suffice in place of the private pilot license and the medical certificate. The Notice of Proposed Rulemaking came out on February 15 of this year in a joint statement issued by the FAA and the DOT. The comment period ended as of April 24, and the highlights of the Notice of Proposed Rulemaking were these. Daylight operations only. You must pass an aeronautical knowledge test. You must obtain an FAA-issued UAS operator certificate, limited to 500 feet of operational altitude, a limit to 100 miles per hour airspeed, limited to visual line of sight, cannot fly over people unless they're directly involved with the operations themselves. So, as was already mentioned by Tony, Amazon has been very public about their wanting to be involved in utilizing this technology for their business. It's very difficult for them to operate visual line of sight if they hope to deliver their packages in a 5-mile radius, and obviously would be delivering them over a populated area and wanting to carry objects. So those are issues that are going to have to be worked through, and all of us will stay tuned, but Amazon has been very aggressive about wanting the FAA to grant them the ability to conduct their business in that fashion. I might mention one other thing just briefly. There are various pilot certificate programs that I've seen throughout the country that have been started, and this has become a bit of a cottage industry. These are entities that will provide training in the operation of UAS. They will issue sometimes a T-shirt and a cap and tell you that you are now approved to operate. I will tell you that none of these entities are recognized by the FAA. The FAA will be issuing its own examination and will be certifying pilots. So to the extent that these types of programs might help someone in terms of learning how to operate a UAS, they might be useful. But to the extent that they charge a lot of money and they represent that they're FAA approved or certified, that simply isn't true. The final rulemaking has been mandated to be completed by September of this year. There have been many commentators that have speculated that that may or may not happen. It may not happen until 2016. But as Tony pointed out, there is new legislation that may move that along. There clearly is a substantial desire and need by the commercial segment of people that want to use this technology to have the decision-making occur sooner rather than later. One last piece that I will comment on, and that's insurance. To the extent that you're operating for a commercial purpose, you want to make sure that you have adequate insurance. Many states require insurance for air operations in their airspace, and you want to check the state laws to make sure that you're in compliance. Even if a state doesn't require it, it's still a good idea to have. There are all sorts of potential claims that might come. The obvious ones would be if you crash one into somebody's property or crash one into somebody on the ground, there would be a need. But I think there will also be people that will be raising privacy concerns, and if you fly one over somebody that feels that their privacy has been violated, you may well face a complaint or even worse, a lawsuit. Many carriers are now writing insurance specifically for UAS. Global Aerospace, USAIG, Allianz, AIG all come to mind. And what you need to do is make sure you understand what the policy covers that you're paying for. Does it insure for commercial operations? Do you understand what exclusions there are? And that is, if they exclude operations over a populated area, you want to make sure you know that. If you violate the exclusions, you may violate the policy and not have the coverage that you've been paying for. Make sure you determine what the deductible is, or what's called the self-insured retention. That's the amount that you have to pay for any claim before the insurance takes over. And generally, people ask, how much insurance should I have? And the general rule of thumb is, depending upon the type of commercial operation, obtain as much insurance coverage as you can possibly afford. You should also consult with a broker to see that your operations are met with particularity in terms of the type of policy that you're seeking to obtain. There has been a rapid development of this technology, and I will tell you that the law has not kept up. It's a very fluid situation, but it seems to be changing literally on a weekly and monthly basis, and as 2015 progresses, we're going to see more changes. So stay tuned. That concludes my remarks. Back to you, Alan.
Thanks very much, Donald. Ladies and gentlemen, we have now passed a milestone of sorts. This is the first time an attorney has presented on one of GPS World's webinars. This is of interest to me and should be to you also, in that it reflects the way that technology is entering society. There are for sure, and have been for a long time, legal aspects to GPS operation and GNSS operation, but this is a new twist, and it just shows how our world is changing when the law gets involved. And thanks, Donald, for that very succinct yet comprehensive presentation. We're going to turn now to an actual UAV. I saw a paper at the Institute of Navigation's most recent meeting, ION, and I was quite excited about it because it combined in one topic heading one title, I should say, two of the hottest topics in GNSS, and that is UAV and jamming. This Stanford team has put together a UAV to detect jammers, and here to tell you all about it, James Spicer and Adrian Perkins.
Thank you very much, Alan. I am James Spicer, and I'm a master's student here at Stanford.
And I'm Adrian Perkins, and I'm a PhD student at Stanford and working in the GPS lab working on the Jaeger project.
So today we're here to describe the project, which we believe is a step forward in the U.S.'s precautions against GPS jammers. The presentation outline will be that I will briefly outline the GPS jamming threat and describe our proposed solution, including its design, how we built it, the safety protocols we have in place to make sure it's as safe as possible, how we tested it, and the results we got before concluding, and then afterwards, at the end of the presentations, we will be available to answer any questions you might have. I think that everyone will have a basic understanding of the threat that GPS jammers pose right now to the aviation industry. But these headlines show that jamming events are becoming more and more common. In fact, it took authorities 2 months to track down the single worker responsible for jamming events at Newark Airport, and over 2 years to catch a trucker driving past on the New Jersey Turnpike. These events show how easy it is to disrupt the very weak GPS signal, and that the U.S. is underprepared for a major coordinated attack by multiple powerful jammers that could take down an entire airport until they are located and shut down. Stanford's response to this threat is threefold. First of all, to protect the system, to stop these events from happening in the first place, but when they do, to mitigate the damage that they cause. Secondly, to toughen the existing GPS system, both on the transmitting and receiving end. And finally, to augment the GPS system with alternative aids, broadcast both from the ground and other space-based navigation aids. We are firmly in the first category. So any solution to the GPS jamming problem has a number of criteria that we have tried to follow. It has to be accurate, must be able to locate the jammer to within 30 meters so that it's easy to locate and shut down with ground-based forces. It has to be rapid to track the jammer as fast as possible to mitigate disruption to both the airport and the airborne fleet. It has to be able to navigate in GPS-denied conditions using alternative signals, and also be cheap enough to be deployed at least the nation's major airports. It must also be autonomous enough to be operable without significant prior training and certification. This is our proposed solution. This is the jammer acquisition with GPS exploration and reconnaissance. This vehicle will be accurate enough to locate a jammer to within 30 meters and has a 20-minute flight time. With its top speed of 22 miles per hour, even fully loaded, this is enough to cover even the largest airport. This vehicle is able to navigate on GPS, but also on alternative signals such as UAT and DME. It's built entirely from commercially available off-the-shelf components, so it's fairly cheap compared to comparable solutions, and it is able to complete a mission almost entirely autonomously from launch to land. The main component of the system is the DJI S1000 airframe, which is built for filmmakers so they can get aerial shots of their set. It's built from carbon fiber and weighs only 4.2 kilos, despite being over a meter in diameter. It has a max takeoff weight of 11 kilos, which leaves us with 6.8 kilos of payload space. Unloaded, it has a top speed of 45 miles per hour. We modified the airframe slightly for our mission, including adding increased space for batteries underneath the vehicle, and also a payload plate on top of the vehicle to which all our experiments are fixed. This is fixed with a quick release mechanism to the top of the airframe. The payload plate has a grid of evenly spaced holes to which components are mounted so that they can easily be moved around on the top of the vehicle to get the optimum configuration for the experiment. This is a photo of the GPS-denied navigation experiment, which can be switched in and out very quickly for the efficient use of the airframe between multiple experiments. This is the machine that flies the vehicle and takes in multiple data and can be modified to take in data from the various experiments we have aboard the aircraft, including the navigation and the tracking systems. This is the GPS-blind navigation system, which takes in alternative signals, including UAT and DME signals, which are put together in a CPU to get ranges from the towers that broadcast these signals. And by using knowledge of the locations of these towers, we can get the vehicle's position without using GPS. This is a photo of the GPS blind experiment, which shows the UAT and the two native GPS antennas. The tracking system takes in the target frequency, which in this case is GPS, and the CPU can calculate a bearing to which the autopilot can then fly the vehicle. This means that the vehicle senses the signal environment and will fly towards the most likely location of the jammer. Briefly, I'm going to outline the safety protocols that we have in place. The vehicle is extremely stable, but we can also implement geofencing to put in locations where the vehicle cannot fly, which can be useful in an aviation environment. The vehicle is self-diagnosing and can diagnose whether a fault is not very serious, and so it should return to its launch site, or whether it has to perform an immediate controlled landing. We tested the vehicle in a unpopulated area and tested the GPS-blind navigation system. We were receiving signals from two local broadcasting towers, and as you can see, the results were very promising. The alternative navigation systems that we tested deviated from GPS by only an average of 16.6 meters over the course of the entire flight. This shows the potential for terrestrial signals as an alternative to GPS when GPS is being jammed or is otherwise unreliable. So to conclude, our system fulfills all the criteria for a good solution to this problem. It is inexpensive. It's built entirely from off-the-shelf components, and the entire vehicle cost less than $8,000. We are planning to transition to full autonomy from launch to land, although it is always able to be taken over by a human at any point. It's extremely safe. As I mentioned, we have multiple safety protocols in place to minimize the potential damage to humans and buildings. It's extremely accurate, and we plan to get down to 30 meters resolution over an area the size of an airport. With its top speed of 22 miles per hour, it can cover even the largest airport extremely rapidly. And finally, it is able to navigate in GPS-blind conditions using alternative navigation aids. Thank you very much for listening. Back to you, Alan.
Okay, everyone, I'm going to introduce our next speaker, Peter, who is the Director of Research and Development for Gatewing, a Trimble company.
Thank you, Joelle. So what I want to present you today is give you actually a brief overview of a solution that is already some time on the market, a few years now, and is actually addressed to the geospatial professional, and that delivers, it's a UAS that delivers actionable data, such as 3D models, 3D point clouds, orthophotos, or just data that can be used to do measurements, such as volume calculations. This slide shows you the distinct components. So on the one hand, you have basically the image acquisition system consisting, of course, of the aircraft. It's a Trimble UX5 aerial imaging rover, and a rugged tablet computer. It's a Trimble tablet on which Trimble Access Aerial Imaging runs, which is our mission planning and monitoring application, and that actually guides you through a flight. Next to that, we have image processing solutions that actually deliver the end deliverables. There are multiple, such as Trimble Business Center, Aerial Photogrammetry Module, Trimble Info US Master, or Trimble Info. So the solution itself is basically a geospatial tool, and I stress the word tool for the professional. Why it's a tool? It's a tool because you use it when you need it. It's something in your own hands. You will use it on the time that you need the data, and you can basically process it the same day and get the data in-house. This is different from the past. If you want to cover a significant area, if you had to or go out and do manual measurements and create data that is not as detailed as we can do today with the system, or have a service company flying over, for example, your mining site, to actually deliver you the point cloud. So it's actually a tool. The main fields of use today are in engineering, in surveying, mining, also specific applications such as stockpiles or road construction, asset management, and also, for example, we see use today in agriculture and forestry, where it's actually more the image interpretation that is important. So the orthophotos are created not just with visual light, but for example also with near-infrared light. And they give you an idea about the vegetation health status of plants, which is of course important for a farmer. Depending on the user needs, you will use a different software tool. For example, for the land surveyor, you will use Trimble Business Center. If you are more a specialist and you are you really require optimal data, you would use US Master or Info. Then an example. This slide actually shows you gives you an overview of where people are using the system today to do in mining activities. So where basically in all places where there are big mines. One obvious gray spot here is the US, and this is of course because of the regulations. I do have to say that since the end of 2014, Trimble has an exemption, and that we now also have a guiding process for clients that want to fly also in mining. So we will see this thing changing soon. Then the UX5 itself, some specifications. The UX5 actually it's a very small platform, only 1 meter wingspan. It's a fixed wing, weight about 2.5 kilograms. It's catapult launched, and you have a high resolution camera, 24 megapixel inside. You see also on the data that it's actually quite speedy aircraft, 80 kilometers per hour, that can sustain a significant wind, 65 kilometers per hour. The purpose of that is actually that you can basically use it in all, let's say, practical conditions, that you would go out yourself and do some measurements. And it also allows us to cover quite big areas. You see, for example, that the coverage at 5 centimeters is 2.7 square kilometer. If you fly, for example, you're limited to fly up to 400 feet, which will be about between 3 and 4 centimeters. You will be able to cover about 2 square kilometer, so which is typically enough for many projects. Of course, you can cover more if needed and actually do multiple flights and then construct one final end product. This slide gives you an overview of the software flow. So it's basically a wizard-like process. You first have a planning stage where you basically design the area. You basically say where you will be flying. You can use different background layers such as Google Maps or OpenStreetView. In the next stage, you will be guided through an automated checklist. These are a number of sanity checks that are being done. You will, for example, check that the sensors are working properly and so on to make sure that you have a proper flight, a good flight. Then you have the flight itself. Flight monitoring stage. During that time, actually the user will just monitor the flight, see if everything goes as planned. He will not do anything specific, but he will just watch the system until it basically goes into its landing stage. Of course, he can interact, he can land prematurely, or he can let it hold or let it come back to his position. But these actions are typically done only for safety reasons when it would be needed. And then finally, there is a post-flight check where you follow certain steps to make sure that you gather all the data and go back to the office to process your data. Just a few impressions. This is actually from an animation movie you can also see on our website, ues.trimble.com. So in this case, for example, when just prior to starting the vehicle will be on the launcher will launch the vehicle. The vehicle will automatically detect the acceleration, put the motor on at the right time, start climbing out in a straight line to 75 meters, and then go to its first waypoint and start covering this area. So while flying, it basically follows straight lines at a certain altitude. He can cover different, so this is just a rectangular area, but you can cover other shapes as well, and you can cover multiple of these areas in one flight. During a flight, the vehicle takes a lot of pictures. Lots of pictures at high overlap, and every picture had its registered GPS coordinates and roll, pitch, and yaw angles. And this information is then used to actually process the data. Finally, just prior to landing, the vehicle will go basically to a parking spot, about 300 meters located from the landing position. Upon the command of the user, the vehicle will initiate the landing and come in at a rather steep angle. See that the angle is 14 degrees. A normal fixed-wing aircraft would not be able to do that, but it is because we have reverse thrust control. So we allow the propeller to actually control the vehicle in the opposite direction. So this allows us to really land without the need of a very big distance. So this gives you an example of the flight. Another example of an application is basically heritage mapping, and I think this is a nice example done not so long ago at Machu Picchu in collaboration with our distributor Geosystems and the Ministry of Culture in Peru. And it's an application that also shows where technology as this can be used. You can use it in very inaccessible places to really start creating 3D models and maps of at very high resolution, up to the centimeter level, which can be make sure that we preserve our heritage. Has been done with the system also at the Chan Chan site in Peru, but also, for example, on Easter Island. Knowing that there are earthquakes and everybody knowing what happens, for example, in Syria and in Iraq, we know that these kinds of things are definitely needed as well to preserve our history for the future. So finally, thank you for hearing my presentation. If you want to contact me regarding anything, so please have my email over there. Also, please go to our website if you want to know more about our product. Back to you, Alan.
Thank you very much, Peter. That's fascinating. Well, the whole thing is fascinating, but I was particularly caught by the Machu Picchu flyover and observation. Very valuable application of the technology. We turn now to your questions. We have ample time to answer at least 4 questions. I think we're going to run a little past the top of the hour. So if you can stick with us, we'll cover some interesting topics that have been elicited by these presentations. Our first question, and I'm going to turn it to Tony first, and then anybody else who wants to comment. We may think that we're on the cutting edge with this webinar, but actually at least one of our listeners thinks that this is, if not old technology, at least it's becoming rather commoditized. He writes in to ask, when will the UAV market move beyond focusing on the drone itself, that is the platform, and get to the important topic of what sensor technology and back-office systems provide the best value to the user? The UAV is a commodity. Tony, you first, and then anyone else who wants to chime in.
Yeah, this is a good statement. UAVs are just platforms. I mean, they're platforms that can do many, many things, and that's where I think all the interest is in UAVs. It's the concept of having remotely flying things you can control to do many things. For sure, as we get to commercialized applications, it's the tools that you're able to bring to the application that matter, not the fact that you're just flying something over a particular object. But, you know, we're caught up in regulations. We're caught up in the U.S. being behind the rest of the world, and you can see that from the nice slide that the Trimble presenter put up, showing, a nice gray area of absence of commercial applications in the U.S., which is really pitiful at this stage, given Australia and Canada and the Eastern Bloc, China, South America, and South Africa. We really need to move forward and turn UAVs into just commodities.
Thanks, Tony. Any further comment from our other speakers?
Yes, Alan, this is Peter. Maybe I'll also want to comment that, for example, in our case, we tried to look at the user and then design a system around it. It's of course something. I mean, the UAV today is a very it's an important part, but it's true, it's a commodity. In the end, it's the sensors, it's the software, it's a combination of the two that makes the product work and optimized and for a specific user. So that's I think that's definitely an important statement.
All right, thank you. We'll turn to question 2 now, which is one listener wants to know, what is a practical ceiling for UAV flight? And I might add to this question, well, there may be a practical ceiling. There's also a legal or regulatory ceiling, at least in the U.S. Then I imagine there's a technical ceiling. How high can small platforms go? And then from the end user's point of view, well, how high can you go and still have usable data? You can think way back, half a century ago, to the U-2 spy plane, very high altitude, capturing data. I think that's out of the question. I think that's out of the question for UAVs. But within the flight ceiling dimension, coming at it from those various aspects, I'll throw that open to any of the speakers who wishes to comment.
Let me just give a quick. For small UAVs, the ceiling the FAA set is around 500 feet. Some restrictions I saw were 400 feet. And I think the regulations, the proposed small UAV regulation for 500 feet. Don could probably clarify that. But for larger UAVs, the Global Hawk is up at 50,000 feet, currently operating and performing the U-2 function. Satellite communications, satellite linkages, you can get all the data you want. So there's really no limitation other than you've got to operate safely, and you've got to get through commercial airspace in the manner that the regulations allow to get up to altitude and to operate safely.
Alan, this is Don, and I can add to what Tony has said. The FAA issued an advisory circular 91-57 many years ago that was essentially guidelines for the use of model aircraft, and that limited operations to 400 feet. The Notice of Proposed Rulemaking that came out in February is now proposing a 500-foot maximum for the usage of commercial UAS. And keeping in mind that in the United States, general aviation aircraft have to operate a minimum of 500 feet above the ground or above any object on the ground that they are flying above. So originally, the thinking was that there'd be a 100-foot separation between UAS and general aviation aircraft, but now the Notice of Proposed Rulemaking is made at 500 feet. I think the thinking is that if people abide by the law, there shouldn't be any interference with general aviation aircraft. I will also tell you that there have been a number of reports from commercial pilots observing UAS at 5,000 feet, at 7,000 feet, and the like. And so the concern isn't the technological capability. We know they can go to significant altitudes. The concern is, particularly by the FAA and all of us that fly, is the safety factor of having an object operate, say, at 5,000 feet that's in a traffic pattern that could cause significant damage to a commercial aircraft and perhaps even greater harm.
All right, thank you. We're at the top of the hour, but as I said earlier, we're going to go a little bit past. We have a couple of more questions, and then we'll return in digital form, perhaps in Tony's next newsletter, to answer in writing some of the other questions that we may not have time to get to on the air. For question 3, could you comment on UAV developments around the world, especially the rapidly growing Chinese market? As our listeners may or may not know, China has probably the most active construction market in the world by perhaps an order of magnitude or two, and use of GNSS in survey and construction is just exploding in China. What about the UAV aspect of that?
Peter, could you just explain your coverage in China there? It looks like you've got usages there.
Yes, China is an important market for us just because of the fact that, of course, so much is going on there on the construction, mining side. So that's an important market. So it's I would say, of course, it's also a place where you see a lot of local manufacturers. I think, of course, the best known one, but then we're on the multi-rotor side is the DJI. But for example, for our, let's say, professional mapping type applications, it's a very important market.
Yeah, there's certainly. I just endorse Alan's comments. I was just in Beijing and the area, and the amount of construction is enormous. A lot of people in a lot of cities, and a lot of people need places to live, and they need roads to get to the places they live. So there's massive construction going on there. So you can see why surveying and monitoring and all the things that would help the construction industry, machine to machine. It's all essential and wrapped up around UAVs.
All right, thank you. We'll move to our final on-the-air question, and that is the line of sight limitation. One of our listeners wants to know, what are the guidelines, or are there any guidelines? What is the maximum range one can still argue that the drone is within sight? Would this extend up to 2 kilometers or 5 kilometers? Again, we're talking primarily for in the U.S. regulatory framework, but is that the same around the world? Don, we'll turn to you first on that.
The Federal Aviation Administration in the United States does not define visual line of sight, and I think probably purposely so, in the sense that it depends on the environment in which the UAS is being operated. So if you're operating in the woods, the line of sight presumably will be substantially reduced from if you're operating in the plains. The idea that the FAA has tried to advance is that we're talking about safety and control. So if it gets beyond your control, particularly because you are no longer able to see it, that would be considered illegal. So there is no particular distance that they've defined, and I gather if you're operating it and the fog rolls in, that might well reduce your visual line of sight, so you'd have to reduce the area of operation.
Yeah, just to basically add, I think in most of the original exemptions, I don't know if it carried into the later ones, but the FAA said you had to have 2 guys, one operating the vehicle and one as a separate observer. And I'm not sure if it can be aided sight. In other words, you've got some magnification capability of some description, binoculars, or I don't know about infrared. If you could use any augmentation to ensure a longer distance, further distance away.
Let me add to that, Tony. Tony, you're absolutely right,
Yep.
and that's a great observation. But I will tell you that the regulation says you cannot use infrared goggles or an aid of that sort.
Okay, so it's what you can see. You know, I can see a good distance on a highway.
Yep.
It calls to mind the new Pathfinder project, where a distinction in environments that you're operating in, CNN, the difference in urban versus rural application, and that I think will become more and more important as at least within the U.S. this Pathfinder project becomes more developed. Line of sight in an urban environment can change very quickly, just depending on what direction or what degree. You know, a shift of a couple of degrees of your orientation can radically alter your line of sight. So there's going to be a good bit of difference there.
That's where this, the projects that will explore beyond visual line of sight with the two projects they set up is particularly the BNSF railway. If we can get ADS-B and other aiding sensors, there's a massive amount of work going on, sense and avoid. This will put some impetus into trying to get beyond visual line of sight and get the tools to put on the commodity on the UAV that will allow it to go further so that some of these applications are financially viable.
Yeah, the railway is talking about track inspections, for example, over 50 to 100 miles, perhaps longer. Maybe fly across the whole state of North Dakota. You've got a straight line of track and fairly little in the way, but still there's going to be factors there to take into account, and they're talking about very long-range stuff.
Right.
Well, we've reached the end of our webinar, ladies and gentlemen. We thank you very much for your attendance. We thank our sponsor, Navcom, a John Deere company, and we look forward to our next webinar, which will be the third Thursday in June. We will keep the UA in our topic. We will turn to ground vehicles. There's a lot of work being done. The driverless car is become nearly as much of a buzzword, or perhaps more so than drones. There's a lot of investigatory work being done in this area, a lot of regulatory exploration to be done, a lot of R&D on the GNSS side. So we will turn to unmanned autonomous ground vehicles the third Thursday of June. We invite you to join us. Until then, I want to thank all of our speakers, Tony Murfin, Donald Chance Mark Jr., James Spicer, Adrian Perkins, and Peter Kosin. You can see their email addresses there if you'd like to address questions to them personally or particularly. And as I said, we will return in print, probably in Tony's June issue of the Professional OEM newsletter, to some more of the questions that you submitted and some written responses from our panelists. This is Alan Cameron from GPS World. Thanks once again to our speakers, to our sponsor Navcom, to Joelle and the staff backing us up in the operations room, and thanks to you, our listeners. Join us next month. Bye now.